Hello everyone, welcome to the next part of our lab 1. In the previous lab, we discussed about how to display any number on the onboard 7-segment display. So basically, we completed the lab where we generated the clock 1 hertz, and using the clock 1 hertz, we display that output of the counter, that is a mod 60 counters on the 7-segment display. We use onboard 7-segment display, and we use only 2 digits of the onboard 7-segment display. Now, in the next lab, we are going to use the onboard 7-segment display, as well as we are going to use the Pmod 7-segment display. Another thing which we are going to do is that on the Pmod 7-segment display, we are going to display the seconds, same as the last 2 digits of the onboard 7-segment display. Then on the remaining 2 digits of the 7-segment display, we are going to display the minutes. And you can see that as the seconds reach the 60, the minutes will be incremented by 1. Similarly, using the reset button, we can reset the corresponding digits on the 7-segment display. So by resetting both the counters. So in the next couple of videos, we are going to complete our tasks too. So this is the project we used in the previous video. In the previous video, you can see that this is our top module. In the top module, we generated the clock 8 megahertz from the 100 megahertz input clock. Then we generated the clock 1 hertz. And from the clock 1 hertz, we generated the seconds counter in binary. We converted into the BCD using binary to BCD converter. And we displayed on the your onboard 7-segment display. So now I'll save this as a separate project. So I'll do the project, save as, lab 1 part 2. So the first thing we need to do is that we need to create a counter for the minutes. So what we are going to do is that we are going to modify this block. And in this block, in addition to the seconds, which are in binary, we are going to generate the corresponding minutes in binary. Okay, so this is the minutes in binary. And here, so this is what we are going to change. So I'll add here the task 5. Okay, this will become a task 6. And binary output. Okay, so let's go to this module, digital clock module. In the digital clock module, we will have the output. It will be same 5 down to 0 because it will go, it's a mod 60 counter. So it's a minute binary. And the counter will have the same as our seconds counter. So we'll have another set of range and next variable. Minute. Okay, so now whenever our seconds count reaches to the last value, say 59, then we need to increment our minute counter. Okay, so again we'll write the code here. So we can take the sequential circuit from the seconds. always at the positive edge of the clock or positive edge of the reset. If the reset is equal to 1, active high reset, then min sec count register will become 0. Otherwise, min count register is equal to the corresponding next value, which is the output of the combinational circuit. Then let's write the combinational circuit always at star, begin, end. And by default, we'll assign the range value to the next variable, that is the combinational circuit output. Then if the range value is equal to 59, okay, so then our next value will become 1, it should be 0, else if, okay, when we want to increment it, when our sec count register is equal to 59, then min count next is equal to min count range plus 1. Okay, so min count next is equal. So whenever the minimum count reaches its maximum value, you have to reset it to 0. Or whenever the seconds reaches its maximum value, you need to increment the minimum count by 1. Then finally assign min of binary is equal to min count range. Okay, so this is how we have designed our mod 60 counter for the minutes based upon our mod 60 counter of our seconds and the 1 hertz clock. So this part is done. Now we have added the corresponding circuit for the counter for the binary. Now similar to the our seconds, we need to convert those minutes into the binary. So that is our next task. BCD, not binary, BCD. So this is our task 7. So convert to BCD for the 7-segment display. This will be 1's digit of the minute, 10's digit of the minute, and this is 100's digit of the minute. So this will be the binary input. This will be the BCD output. Okay, so this is my binary to BCD conversion. And then I need to display it on the onboard 7-segment display. So for onboard 7-segment display, I will display on the first 2 digit, I'll display seconds, and the next 2 digit, I'll display the minute value. So initially we were displaying the 0, so we will display now minutes value. So this is my task 8, that is update the onboard 7 segment display. Now another thing we need to do is that we need to display the seconds on the Pmod 7 segment display. For that, again, we need to add the logic for the Pmod 7 segment display. Okay, so now my next task, which is task 9, is to display seconds on Pmod SSD as well. We are already displayed on the onboard SSD. We want to display it on the Pmod 7 segment display. Now we'll again write a similar function. So I'll just do the copy paste, but I will change the name of this function. This is for Pmod 7 segment display. Clock will remain the same. We will have only 2 digits, so we can remove the digit 3 and we can remove the digit 4. And in this case, it was a Pmod, so we'll make it as a PSSD cathode, and this will be the PSSD cathode, and then the PSSD anode. Okay, so this is how the our Pmod display we need to write. Again, the logic will remain the same. At a particular clock speed, we will design a counter, and we will generate, say, around 1 kilohertz frequency, and at that frequency we'll switch between the digit 1 and the digit 2, and appropriately we'll display the value. So let's add this file. Okay, so I'll add this one, and I'll mostly take this from the board display. I'll just modify this board display file. So I'll first take the code of the board display one and then copy into the mod display. Then I'll do certain modification. First is the name, that should be PM. Then I'll remove the digit 3 and digit 4, and my anode is only 1 bit. Okay, so cathode is 8 bit and anode is 1 bit, and again the name should be P cathode and P SSD anode. Okay. So another thing which you need to remember from the data sheet is that the corresponding Pmod SSD and the anode signals are active high, and the onboard SSD are the active low. So you need to keep that thing in mind while designing your circuit. Okay, so these are the things you need to keep it in mind. Okay, so what we are going to do, this counter will remain the same as this counter. We don't need to change. Since we have only 1 digit, so what we are going to do is that we are going to use only 1 bit of the counter register. So when that bit is 0, we will display it on the digit 1 digit of the 7 segment, and when that display is the digit is 1, we will switch to the second display. Okay, so that is something you need to keep in mind. Then here I need to change everything to the corresponding Pmod. So what I'm going to do is that I'm going to define this variable as it is, because as you know that I need to do the inversion before I send it to my Pmod 7 segment display, because it's an active loop. So what I'll do is that I'll define this as a to 0 variable. Okay. Another thing I need to keep in is that, again, these are the hardware specific thing. The cathode, the the SSD cathode is a 6 bit because there is no decimal point present in the PSSD Pmod 7 segment display. So that's why the cathode is not a 8 bit, it's a 6 bit signal. Okay, again, these are the things which are given in the data sheet, that the cathode of the 7 segment display is 7 bit for 7 segment, and the decimal point you cannot control. Okay, so I'll define it as a 6 bit, and then I'll define it as a 6 bit. And then what I'll do is that I'll remove the corresponding this 1 bit. Okay. I'll also remove the concatenation operation. So note that we have just taken this from the board 7 segment display file. So these are active low signals. So I have to make sure that I invert their values before I send it to the your cathode. So I'll make this as a non-rich, and what I'll do is that assign PSSD cathode is equal to okay. So I need to use the invert here. The code is not working. Okay, yeah, and it should be this one. For anode, it's not an issue because it's just a 1 bit, so you can start with any digit at any time. So the anode is, I can say that I'll just make it as a 1 bit 0. Okay, so this I can directly make it as a PSSD anode. Okay, so this is the one, and here also I'll make it as a PSSD, and it should be 1 bit 1, and I'll just copy all these things as it is because we are going to display the same manner on digit 1 and digit 2. So since I don't have the digit 3 and digit 4, I will remove that part. Okay, so I have only the digit 1 and digit 2, and based upon that I'll be switching between the digit 1 and digit 2. So between 0 and 1, and this will happen based upon the 16th bit of the corresponding counter. So this one is inverted before you send it out here. So now this PSSD cathode, okay. So we'll go to the main module. This PSSD cathode, I need to define it at the output. So this is 1 bit anode signal, and this is 7 bit. This is for the Pmod SSD. Okay, so with this now we have now added the
Pmod SSD in our project, and we have display. We are going to display the seconds on the corresponding Pmod SSD. Now in the next video, we will complete the remaining part where we will update our XDC file, and then we will display the data on the, we will see the, see the demonstration on the Basys 3 board.